What's up, YouTube? Welcome to this video on abstraction in software design with examples. This is potentially the third part on abstraction. As you can tell from the fact that there's 3 versions or 3 videos on the same subject, it must be important, right? Well, not only is it important, it's also difficult to explain. And so I felt after the second video that maybe some people want more code examples. And so I thought I'll walk you through the decision process, the design process for some of these abstractions, with the hope that that'll probably help you better understand the reasoning or the thought process involved in creating or formulating abstractions and why in some cases certain things are valid or invalid. Today's video is going to be going through some code. The code is all available on my GitHub. As I talk about this code, I'll put links up here for those videos and potentially also in the description below, depending on what's going on. So I want to talk about, with examples, simple things. They could border between encapsulation and abstraction. You can ask me what the difference is between encapsulation and abstraction. I can probably try and give you what I understand. For me, more like abstraction is about the implementation of what you're doing, versus abstraction is more from the perspective of the user or from how you plan to use it. For the same encapsulation, you can have different abstractions depending on your perspective, meaning I could create an abstraction around this, let's say, object that's already encapsulated, right? For this use case or for this perspective or this system that I'm using that thing from a different system or from a different perspective within the same system, I might need a different abstraction for the same object. So even though there's this notion of encapsulation within this class, how I want to see it or use it from the perspective that I come at, the abstractions could change, whereas the encapsulation is not necessarily changing based on the abstractions. Abstraction is more dependent on the call side, if you will. Not call side, but more from the calling perspective. While encapsulation is essentially done at a class level. And of course, I can tell you I put you a link to one of the documents I found. Very, very well-known people in the software industry are trying to explain encapsulation and abstraction. And you can tell from all the descriptions that there is no clear distinction. For all you know, back in the day, in the 60s or whenever the term encapsulation and abstractions kind of started being used in software, they might have come from different camps, if you will, and they wanted to retain the 2 different words to mean 2 different things when they're potentially the same thing. But I do see it as different. I can't tell you exactly why when I would call something abstraction, when I would call something encapsulation. So just follow along. I'm going to give examples from the C#.NET framework. Initially, just so you understand some ideas, and then I'm going to explain by example certain things here. I'm just going to start with the simple things and get more involved. All right. Okay. So put on your seatbelts and let's get started. So in .NET, we have a list class, right? A list of T, for example, the generic list. If you come from a computer science background, then a list would imply like a linked list or a doubly linked list, not an array, for example, right? So in computer science, we have the notion of arrays and then we have a linked list. Of course, they're not the same. So would it surprise you to find that the list of T implementation in .NET is done with arrays? And you're going to think, but then Shiv, how do you expand on that? Well, that's managed internal to the list. As it grows, as you add more and more items, they have an algorithm that will say something like increase it with the size, increase the size of the array to the next prime number that's double the existing number, right? So if it's 50, at this point in time, the size of the array, then make it 100 and then get to the next prime number, whatever that is. Whatever the algorithm is, it's hidden from you. It is abstracted. You don't need to know the details of those things. The fact that list is implemented as an array, and each time it has to grow, it has to not only allocate a new location for contiguous memory, copy all the elements from the previous location into the new location. Now, that's an implementation detail. You don't necessarily need to understand it. And when you're using the list, you certainly don't understand or need to know that's truly the case. So that is an abstraction from the point of view that you don't need to know the details of that, the implementation details, what's being used behind the scenes. However, the entire list class is an encapsulation. Generally speaking, in languages like C#, you could say encapsulation to be things like what's hidden and what's not. So the access modifiers, public, protected, private, these are ways or means to achieve abstraction, encapsulation to some extent. Methods, same thing, access modifiers and property and methods. Or even classes. Okay, another example in the list class itself, by the way, is the sort. When you call sort, you're not telling the list class, or the list class is not asking you for help on how to sort or what is the algorithm to use for sorting. And it turns out that internal to the sort method, there's an implementation of a strategy. The strategy design pattern, you might want to take a look at my video here. I have a video on the strategy design pattern. I think talk about this feature there as well. Idea is the same. You need to sort something. The list will decide which algorithm to use, one of three algorithms to use. Depending on the content of your list and this number of elements in the list, it will decide what strategy to use. It's abstracted from you. You don't need to know that. Right? That's the implementation detail, once again, that you don't need to know, you don't care to know. And the list classes decide we don't need to. This is not the user would not know necessarily what's the best strategy to use, right? So that's an abstraction. All right. Now, this next example, the link to the source code will be available in the descriptions below this video. This was a video I made on custom data structures. I'll put a link to that here. So you can either get to the video and watch that video on custom data structures. I'm going to use that data structure here in today's video to explain another form of abstraction, right? This is sort of the more simple form, but nonetheless very important form. Nothing about abstraction, no matter whether simple or complicated, is not important. All right. So let's look at this code example here. So this one-to-many thing I have here, one-to-many, it could be a dictionary or some whatever else. In this case, it's a dictionary, but one-to-many map was the data structure we created as per certain requirements I provided in that video. And the source code is linked in the description there. I also linked the source code in the video description here, so you can get to the source code directly. All right, so you've got the source code, and you've basically written this one line of code, which is what I've done here. Now, the way this data structure works is it allows a key, in this case, a certain message, to be associated to multiple things. In this case, I've got states. So a given state or a given message can be associated to multiple states. The use case for this is given at runtime, given the state, give me the message. Right? So even though you know from your data's perspective that it's the same message for all these states, so you don't want to duplicate the same message if some states share it. When you want to search for it, you're kind of going backwards. You're saying, okay, well, I added the data like this, but in reality, when I use it, I need to be given a state, get me back the message associated to that state. So that's the sort of the feature of this data structure. Okay, so that's what we're trying to do here. And you might say, yeah, that's cool. This is perfectly fine. Now, this discussion I plan to have now is bordering around inheritance versus composition. Now, the general saying is prefer composition over inheritance, and it's a true statement for the most part, but let's not generalize and just use that dogmatically. I want to explain my reasoning for it in this particular case. It's a common mistake, let's call it that I see a lot. And I do it myself because sometimes the overhead might not justify the benefit. Okay, but I'm going to explain that here. The question is, simple question, if you have a customer object in your customer type in your project, and you want a list of customer, what would you say? You just use the generic type, list of customer, right? List of T. You're effectively inheriting from list of T to create your own list of customers. But is a list of customers a list? Think about it. If you know the Liskov substitution principle, the basic idea is that you could replace any list with a list of customer. And is that what you're trying to do? I mean, maybe in some areas you want to iterate over something, whether it's a list of customers or a list of orders. You've written this generalized method that allows you to iterate over. But is that to say that all customer objects and all order objects can be treated uniformly. No, of course not. So a list of customer is not a list. It's a customer's list, but it's not a list in that sense, right? So generally, you shouldn't be inheriting from list of T. You should you should composite a list of T internal to your class. So it uses, not is. Has a, in this case, it has a list of T internal to this class, rather than it is a, meaning it descends from a list of T. All right. So we're going to see an example here, so that hopefully that'll make sense to you. But that's the general argument / discussion. And you want to have this, in your own head, right, when you're designing your own systems. Is this thing a list or does it have a list? Right? Now, typically for domain classes, I feel domain classes has a list, like it's a composition. And we'll do the example here. Now, typically for domain classes, I feel that domain classes has a list, not is a list, generally, for the most part. So anytime you have a collection of something that's a domain class, you might want to try looking at it from the other perspective. It's not is a list, but it has a list. It's composition versus inheritance. So I'm going to try that over here now. So this works fine. It's not like there's anything wrong with this, right? But is this readable? I mean, do you understand from a domain point of view what it is you're doing? Now, in this particular case, the map essentially only has this one method here, right? And it's a abstract base class, or this thing descends from. It has an indexer property, as you can see over here, right? It's using the indexer property. So it's not a complicated thing. It's not like a list. List has all these features you may not really want for a list of, customers, or list of rules in this case, or whatever it is, right? So what would happen if we said, we want our own specialized class. Let's call it something. Let's give some methods that we can relate to from our domain's point of view. Okay. So we'll give this class, we'll define a new class. It doesn't inherit from this one-to-many dictionary map, one-to-many map dictionary. It composites. It has a, all right. So let's start with that. We'll have a class called, let's give it state messages, and class. And as a private read only, it could have I could use the abstract class to one-to-many map base, and it is a string state. And let's call it, but we'll new up a dictionary, right? The one-to-many map dictionary, giving it the string and state. So that is the it's a composition. Right? This outer class state messages composites some other class, right? Now, I'm designing this class's interface, the public surface, as how I would like it and how or what the business might use, the terminology, the vocabulary the business might use in terms of either saving this, creating that collection of messages to state, and or retrieving. Okay, so let's try that. So here we have a method. We want to be able to add a one-to-many mapping, but of course, from a domain point of view, it's not going to be called one-to-many mapping, right? It's going to be given a different name. So let's call that. We just say add or associate message to states. So it's more domain centric, and the message is that, and the states is an array of state. You can have an IEnumerable as well, probably better. I prefer generally to have IEnumerable of a, so if you're telling the call site, you don't intend to modify whatever they give you here. Implementation. So of course we have our instance here from the private member. We can just forward that on. I see. The interface here is asking for an array of states. So I'll just make that an array of states. All right. So from the public surface, you're seeing associate messages to states. That's more like the domain-centric vocabulary. Internally is forwarding it on to whatever it is compositing. In this case, the one-to-many dictionary, and it's saying add one-to-many mapping, which is more specific to that class. So in this case, the abstraction is giving us a more domain-specific interface, more domain-specific usage, while the implementation is hidden from the user. Now, this one-to-many has a indexer property. So let's see what it would look like to implement that. So this will give us a state back, and this would be where it is a string. Is it a string? Oh no, sorry, it's supposed to give a message back. So given a string, taking in a state, should return the message. So again, we can use the one-to-many maps indexer here, provided with this, the value, which is the state, and it will return the message associated with that state, right? So on the usage side here, if you were to abandon this, let's say I start here with all right, just fix the naming here. So if you look at the code here from a domain point of view, this would make a lot of sense since it's got vocabulary that the domain would be using here. However, this is still it's not clear. What are you doing here? Right? It's a very sort of C#y thing. It's not domain centric. So you might want to expose a method here. So let's do that. We could have a method here that returns to us the message, which is a string. So you could get state message given the state, get back message. And in this case, we could internally use the indexer. So here we could use the one-to-many map of the state. Oops. Right. This might make more sense than that. All I'm trying to get across here is the abstraction for this class is very centric or centered around the use case in this application. Internally is compositing, or has the one-to-many map. That one-to-many map could be used in different places, in different systems, or in the same system to produce a different, or to be used in a different scenario, and thus the abstraction around that could be different. So even though the implementation details might be the same, the abstraction could differ based on the use case, right? So the abstractions are generally built for the use case for what you want, because you can make much more generalized abstractions, but those become a little harder to use and less useful in many ways. But I'm talking about mainly abstractions for these systems you're trying to build. All right, so now the next discussion I'm going to have is a little more involved. It's a little more detailed. Okay, so I'm hoping you guys get value from this, and I'm able to do a good job trying to explain the idea here. All right, so I have a service. I'll try and zoom in here so you can see. Oh, I see it's got the, okay. Hopefully you can see this. It's got some endpoint here, and then it returns, in this case, it says with image URLs. It returns movies, so it's the notion of some movies with the title and image URL, and so on. So there's multiple movies coming back. Each one has a title and an image URL. There's another endpoint that says movies with categories, and that's the endpoint here. And when you call that, it returns movies with the category. No image URL this time, just a category as a return with the same title though. So if you look at this title, Star Wars Episode 4, New Hope, and you go that here, you also see Star Wars Episode here, New Hope. And there's another third endpoint with year, and the year, you can see it says that there. and does the same thing. This time it returns the year. So the title is common, and the different endpoints add additional attributes where the different attributes are different attributes of the same movie, right? So the service provides us with 3 endpoints, each one giving us a little piece of the puzzle, if you will. And while we are interested in seeing the whole movie, meaning a single movie which has a year, a image URL, and a category, right? So our task is to build a system, or let's call it a gateway in this case, the class. The gateway is typically the class that makes a call out to some service builder or design this gateway that does the work for us, right? So let's see how that's going to go. We're going to go to some extent iterative process, so you understand the reasoning or thought process I would have and why we end up with a certain abstraction at the end of all of this, right? So we have 3 classes. I'm calling them IMDb movie with category, and it's got the category property here, then movie with the image URL, and it's got the image URL property here, and the IMDb movie with year, and it's got the year property over here. So there's 3 different DTOs, if you will, and they will be used by our gateway. We have a gateway implementation here that has these 3 public methods. I'm just doing this. This is not production quality code here. The link for the movie service that you find in the description is production quality code, but the code I'm showing here is not. So if you want to look at more production quality code, please look at the source code on my Git repo, not this one. This is more like the intermediate version. So I'm not spending a lot of time trying to give you a full out robust implementation, just for example's sake here. Get IMDb movies with category returns the collection of IMDb movie with category. Get IMDb movie with image URL returns a collection of IMDb movie with image URL, and so on. So there are 3 methods here, right? So the gateway class is done. And this class can give us access to that service. So the call side, a caller, let's say I'm using the gateway, I'm the domain class. I want to use this gateway, and this gateway gives me these 3 methods. So cool, that's fine, it'll work for me. But the heavy lifting of the fact that this service is giving me these 3 endpoints with these 3 weird IMDb movie with category, with year, with image URL, and then it becomes my responsibility as the domain class to like join all these images, right? So I would have called the service 3 times, right, for the 3 different endpoints. Each of them returns to me a collection. I'm going to have to, for every one item in the first collection, find the appropriate item in the next collection and the next collection, extract the 2 properties, and potentially construct a whole nother DTO that has now the 3 properties, the title, the year, so 4 properties, title, year, category, and image URL, right? That becomes a domain classes problem now. Even though the gateway is giving me access to the service, I still have to do a bit of the gymnastics, okay, which is the call 3 times and do the, let's call it a join of the 3 different models. The other thing could be that, so if I look at my IMDb movies thing here, there is now this 4th class here, which is the combination of these 3, right? So IMDb movie. So the question becomes, who should be doing that, the 3 calls and the joining, right? From the business's point of view, they don't need to know that to make 3 calls. Right? I don't want to get caught up in that services implementation. Okay, you got to make 3 calls to get the data I'm asking for. Well, then, like, why do I need to know that? And the same with the joining part. Like, that data model is not working for me, so I need to join this. And now, for whatever reason that service is the way it is, I still can use the data. I just don't see it. I don't see the data in the way that they are seeing it. Right? So I need to have my own version of that data. All right. So you can see already that the gateway should be doing the implementation. The gateway. So I make one call to the gateway, get all movies or something. The gateway can make those 3 calls. The gateway can do the mapping of the joining of the different movies and return to me a IMDb movie in this case, which is the combination of all the properties. So it can return to me a collection of IMDb movie. All right, cool. So we've already seen that the gateway has to take on that responsibility, which means the code that was sitting in my application has now moved out to the gateway. And the reason is that the business side shouldn't have to know or deal with those nuances. Okay. Now there's another, I'm going to just pose another problem here so we can have a decent conversation about some abstraction problems and seeing how we can resolve, or what leads you down this path of a solution so that you're sort of gaining that knowledge. You work with another service, let's say, and this service says, well, I'm going to show you what it gives us. And it's not necessarily hypothetical, but just right. So it is a database, but let's pretend it's a service, and let's say that service returns to us the data exactly like this. So it's 3 calls, where one call gives us the movies, the other one call gives us the genres, and the third one gives us the association between movie and genre. All right. Whether that's a service or a database, doesn't matter. It's coming in this fashion. Okay, so let's assume for now it's a service that has these 3 endpoints that gives us movies in this fashion, and the genre, and then the association. So again, you would have to have a gateway that makes that call out. And when it has to make the 3 calls. So let's say we already know now that going in that the gateway has to make the 3 calls, right? So the gateway making the 3 calls, the gateway has to somehow figure out how to construct a movie where this combination, if you will, the joining would have to occur such that for every given movie, we have to find out its genre, and the genre comes from this table, but an association, the title of the genre comes from here, right? This is simple RDBMS data modeling. I'm not going to go into the details for those of you who don't understand this diagram, but for those who do, that's the primary key, that's the foreign key. So the movie ID is foreign keyed in these tables. And this is also unique. The title is a unique index. The title is a unique index here. The idea being here that a movie, even though we don't have the need for it in our application, from a data model point of view, a movie can be associated to multiple genres, which of course in real life, that's what it is, right? A movie is not just a drama. It could be action, comedy, or something, two genres. We're not interested in that for this simple example, but this data model supports that. All right. So here's a service that you need to make 3 calls. You get the data like this in this fashion, and you understand intrinsically by documentation that there's this relationship between the data that comes back. And again, you have to join that up into a movie of some kind so that you have a movie. Would it be IMDb movie, which is the other service, IMDb being the service? And let's say in this case, because the genre is so it's like there's a lookup here, right? So there's a finite set here. It's not free form. There's a foreign key, and this is a finite set. So we say, you know what? Let's have an enum for the genre in our system. And now you're looking at these 2 different gateways and saying, okay, well, that one calls it a category. This one calls it a genre, and that one serves it's a string. And over here, you're saying it's a string, but you want to map it somehow to an enum. Once again, you have to think now from the perspective of these 2 services, providing you with slightly different data. And essentially what you're doing is saying, what do I need? So getting caught up with the services. This one gives me that, this one gives me that, this one gives me that. Suppose business is getting all muddled with all the complexities. I'm saying, listen, the business has to say, okay, the domain. But you as a programmer are thinking from the perspective of the domain. What do I need? I need a movie. What should it look like? Well, it should look like this. What I want that gateway to do for me. Get all movies. Don't bother me with all the details. Just get me all the movies. And give me the movies in the way I describe a movie for myself. Not how you decided or how that IMDb service decided. The other service, the one with the data model kind of thing. Same thing. Get all movies. Give me back my movies. My movies. You have to make 3 calls, 1 call, 15 calls. I don't care. I don't want to know. Right? Same idea. So the moment you start thinking of the problem, the abstraction, from the perspective of what you as a user of the thing would like to see, how would you like to use it, you're more likely to make a good abstraction. Don't try and generalize right off the bat. What do I need right now? Right? The future can come in the future. I find many times you account for some future possibility, it never occurs. And now you're dealing with a higher level of abstraction that is making things a little more complicated when they could have just been as simple as what you need now. right? So I'm going with what you need now. So our gateway would have to make, you call the gateway with one call saying get all movies. It has to call those 3 calls, most likely in parallel, so that you don't end up making kind of serial calls. Those 3 endpoints will be called in parallel. They'll return as fast as the one that takes the longest. You do the join. You do the map. Now, you do map it from the, let's say in the case of the IMDb thing, to an IMDb, from an IMDb movie to, let's say, movie, our domain model. We do the same with the other gateway. Right? So the interface, the public surface of the gateways would be the same. Why? Because we have the same need, whether it's this service or that service. Our need is not changing. It's the same need. So why would it change? Right? So once again, if you look at it from the perspective of the domain side, what does the domain want? What does it need? How would it like to use? And if you design your abstractions from the point of view of the domain, when I say domain, I'm saying generally any system you're building from the perspective of the system, not from the perspective of this case, the services. You'll likely arrive at a good abstraction. It might take you a few tries, but generally speaking, you'll arrive at the good abstraction because of the fact your perspective is the same. Whether I'm talking to this service or that service, I need the same thing from both of them, right? Now, what if I got that data, the same data, this data model thing from a database in the same fashion, right? The 3 tables and all that. Well, if you remember from last time's video, I talked about the stored procedures also being an abstraction. So if you're using a database, we have an opportunity where we can say, you know what, that joining of data, the database is far better at that than the C# code is going to be. So I'm going to delegate that joining aspect to the store block. Plus, by doing that, my C# code is being decoupled from the knowledge of the database, the data model. So that's again a good reason for using a stored proc. Stored procs produce or provide an abstraction in such a way that you're decoupling your C# code, your application code, or whatever, doesn't have to be C#, from the knowledge of the data model, allowing your data model to evolve over time. If your business needs don't change, the stored proc can continue to play this role of decoupling the application side from the data model side. You'll have to keep modifying the stored proc, but because the requirements are not changed, the stored proc should be able to map whatever changes you're making back to what the business, the domain side requires. So now we have 3 implementations of the same sort of service, if you will, coming from different angles. One is a database, let's say toward HTTP, primarily. There's another level, another kind of abstraction that is very rarely talked about. And I'm going to show that by way of code here. I'm going to explain the problem, then I'll show you the code. What would happen if that service, the HTTP services, the IMDb or the other one, had a problem? How do HTTP services sort of communicate problems, right? Status codes, HTTP status codes. Okay, so the status, if it's not a 200, there's a problem, generally speaking. Any 200 family, I mean. So if it's 300 or a 400 or a 500, but 300 is not a problem, but 400 series and 500 series are problems. So generally speaking, when you're working with HTTP as the protocol, services respond in an HTTP fashion. So now you want to take that status code and somehow give it back to the domain side. To me, I'm the class side was using the gateway. I don't know HTTP. If I knew HTTP, I would ask that gateway to do the work for me. And then I don't want to know. Which means that abstraction that you built, that gateway that you built, cannot let leak. That's when one of the ways to consider a leaky abstraction is when that HTTP-ness, if you will, of the gateway leaks into your code. I don't know HTTP. I'm the business side, the domain side of the application. I don't care to know 200s and 400s. Why are you bothering me with that detail? But then the question becomes, then how does that gateway inform me of a problem? Exactly, throw an exception. So the gateways are going to have to translate some HTTP things, or codes, to C# exceptions that are, again, domain-centric. It can't throw an exception that is so weird and cryptic from that service's point of view that I don't understand in my domain. So if I said, create this movie, I didn't show you the endpoint, but if I said create a movie endpoint, given a movie, our model, the domain model, not the IMDb movie, the gateway would have to map our movie to an IMDb movie, send that across to the service. The service would have to create that movie and come back. If there's a problem creating the movie, the service might respond with a 400 likely, saying there's something, you made a mistake, there's some duplication, whatever. And now that gateway would have to translate that HTTP code to an exception, throw a specific exception indicating clearly what the problem is, a domain exception, and the message would likely contain the information that you got back from the service, in case that's helpful. Hopefully that's helpful, right? All right. So there's another feature of abstraction, which is hiding. In order to hide implementation details, you're also having to catch exceptions and not let database exceptions fly into your system or HTTP exceptions fly into your system, because you may not know that there's a database involved. You may not know there's an HTTP anything involved, and you don't want to know, right? You don't talk in that language, and you want to decouple yourself from that language. That's the point of an abstraction, hiding the implementation details, giving me a perspective of that gateway from my perspective, so that I don't know about HTTP or databases, but I want a movie, because get me all the movies. I want to create a movie. Here's a movie. Please create a movie. That movie class, DTO, is my class, the domain-centric class, not IMDb movie or the ones that have all the three things split up. All right. So I'm going to show you some code on the database side of things so you understand what I'm saying. So imagine this model here. And we are going to look at the database stuff. And the code for this is again this is from the movie service source code, the link to which is in the description below, the source code. But you can look at that code yourself. But I'm going to just bring your attention to a couple of things. The gateways. This is the sort of the production quality gateway in that movie service application. I'm just going to show you a few highlights here. It's got a get all movies. Public method returns a movie, not an IMDb movie, but a movie. This movie is the domain movie, if you will, model. And it has a genre enum rather than a string. It's not called category, it's called genre, and it's called enum, it's not a string. Okay, that's the domain model. And this gateway is talking or returning the collection of movies here. Internally, it is making, in this case, concurrent calls to the three different endpoints, the with categories, the with image URLs, and the with years. And once it makes those three concurrent calls, if all is success, this is where the exception handling takes place. I'll dig a little deeper into this. And then if it's all okay, as in there are no exceptions, it will then construct from all the data, all the content that came back, a collection of IMDb movie. Now, this is not the domain model. This is the model of the service. Okay. But we're still inside this class. And then it does a join and a map. It says, give me the three movies. Okay. Join and map it to a movie. So what it's returning here is an enumerable of movie. That's what this method does. It returns a collection of movie. It does the join and the mapping. So this one method is doing all of those things we talked about. It's making the concurrent calls, so 3 calls instead of 1, 3 internal calls. And then it ensures all the calls have succeeded. If any of the calls have failed, it will have to take measure in terms of throw an exception, convert that HTTP stuff into an exception, right? And you can see the code in this source code if you wanted to know the details. And then it does the joining and the mapping, if you will, joining of these 3 movie types into one, and while at the same time mapping it to a movie here, right? Now let's look at the database side of the equation. So this is our movie data manager in the same code base. And I have a method here. I'm going to call it the create movie. I want to call the create movie, call it create singular. Okay, here. Given a domain movie, it will create a movie. It will return just the ID of the newly created movie, right? Now, as you remember from that diagram, the title was a unique index, which means if I try and create another movie with the same title, it's not going to work. The database, if you use databases, you'll realize the database will say something like duplicate key row violation or something like that. It's like it's a different database to have different language, but duplicate key row and something. I say, what? So here's my gateway or my data manager here, both are an abstraction. And you don't necessarily know or want to know from the domain side of things that there's a database involved, because you're talking in your language. And if there's something going on with the database and whether there's a SQL Server, Oracle database, or a database, you don't want to know the details. However, when you go to create this movie and you end up with a duplicate title, you get back a database exception thrown saying duplicate key row or whatever it is. And two problems occur there. One is the leaky abstraction. The language is not businessy. It's like, what duplicate key row? Like, what are you talking about exactly? Right? You don't understand that. Unless you know the details of what the implementation is, this exception message is not going to make sense. Plus, a DB exception type is flying out of this data manager. You don't want that either. Right? So these are leaky abstractions. In many ways, leaky. The messaging is not quite correct, so you have to know implementation details. Secondly, the type of exception, DB exception in this case, is also a leaky exception. So what do you do? Exactly. So if we look at the implementation here, don't worry about not understanding. Basically, it's using AD.NET to insert a movie here, right? And if it all succeeds, it returns the newly created ID of the movie. However, if there's an exception, DB exception, we are catching all DB exceptions. In this case, we only know the one scenario. There's the message. Duplicate key row in object, an object, DB movie. So the language is a very databasey language. So in object DBO movie, like even Des might get thrown out with that, right? What do you mean object DBO movie? What object? What is DBO.movie, right? So we catch the exception. If the exception message contains some words like this, we know this is the problem. The problem is the duplicate title. We throw another, this is a domain exception, and duplicate movie exception, where it says a movie with the title of so-and-so title already exists, please use a different title. The messaging is more, and please also make sure you always include the inner exception if you do such a thing. Don't ignore the inner exception here. Right. Idea, what I'm trying to show you here is that this code is catching the original exception, translating it, transforming it, however you want to call it, into a domain-centric exception so that it's not a leaky abstraction. So an abstraction can or should always go down to that point where you want to make sure if you're trying to do a good job of hiding abstraction, hiding the implementation details, then you should also go down the point of exceptions and take care of those exceptions. I don't mean going overboard and catching any and all exceptions and imagining you can handle all the scenarios. Just as long as you know have occurred, you need to address those. And if you've never encountered them, that's fine. Don't try and make some overly extensive way of trying to handle exceptions. As you can see here, we're only handling the one case. We know it's DB exceptions. If it's not this, then we'll rethrow that exception anyways. And then maybe if we find that that's a common scenario, we'll probably have a little more elaborate logic here to determine which of these exceptions or the messages that we want to handle that are common. In this case, only one common scenario. But if there's more, we'll add it. If not, just rethrow the exception. And then you'll know when you see that exception eventually in production or something, should we be handling that as a domain exception or not, right? So don't try and go overboard right off the bat. But let the code evolve. As your needs arise, let the code evolve. Don't try and sort it all out in the one shot. So I'm hoping that the examples are not too complicated. What I want to also talk about is some of the things you're looking out for or looking to achieve when you abstract, when you create an abstraction, right? Ease of use or simplicity or ease of use. The abstraction has to be expressive, as in from the point of view of the business. Like you want to define an abstraction so that it is expressive from a business point of view, kind of like this. The first example we did, even though it's a simple example, I want to just show you that. This associate messages to state and get state messages. It's a much more expressive abstraction. All abstractions are trying to achieve that, not generic abstractions, but more kind of specific abstractions will achieve this expressiveness, simplicity, ease of use. In some cases, abstractions provide you with, some cases, better performance. But If you look at that list example I gave you in the beginning of this video with regards to the implementation of .NET's list of T being an array, well, it gives you performance, but of course you have to understand that if your list is going to be this constantly growing thing, maybe you want to set the size of that list ahead of time so that it's not having to grow that list before or each time you add more items, right? If you already know you're going to be adding at least 3,000 items, then just set the size to the next prime number above 3,000 or something like that, right? All right. So I hope this video has been useful and helpful. Hope you learned a few things. If you have liked this video, or if you haven't liked the video, please give me a like. Please also invite your friends, your colleagues, anyone you know, catch them on the street, send them to my channel. I'd appreciate that. And I'll see you next time.